Today we are going to look at set operations. The operations of union, intersection, and complement. These set operations are similar to the operations of addition, multiplication, and subtraction of numbers respectively. Now let's look at each one of them. First is the union. The union of two sets, A and B is the set of all elements, belonging to either A or B. The union of two sets A and B is denoted by A union B. And we define A union B as A union B is equal to the set of all x such that x belongs to A or x belongs to B. So that is it for union. Now let's look at some examples on union. If set A is equal to 1, 2, 3, 4 and B is equal to 2, 3, 5, 6, C is equal to 1, 4, 7. Find I, A union B, A union C, and the third one, A union B union C. Okay, we are going to solve these three problems. Solution. The first one, A union B, is, now let's write out the elements of the set A and the elements of set B. So if we take the union, we will have 1, 2, 3, 4, 5, 6. What have we done here? We picked the elements that are found in set A and set B. We picked each of the elements and we put them down as another set. We have not repeated any elements. For example, we have 2 in set A, we also have 2 in set B, but 2 has been written just once in the union of A and B. So here is A union B, the set that contains all the elements that can be found in set A and set B. That is the union of A and B. The second one is A union C. A union C is 1, 2, 3, 4 union set C is 1, 4, 7. The union will be 1, 2, 3, 4 and 7. And the third one, A union B union C, is equal to the union of the three sets. I'll write out the three sets. 1, 2, 3, 4 union 2, 3, 5, 6 union 1, 4, 7. So if I take the union of these three sets, I'm going to get 1, 2, 3, 4, 5, 6, and 7. So that's the union of the three sets. Now we have example 2. If A is a set of all x such that x is an integer and x is less than 6, and B is a set of all x such that x is an integer and x lies between 2 and 10. Find A union B. These two sets have been written in set builder notation. We are going to use this description to write out the elements of the two sets. Set A is equal to the set of integers such that x is less than 6. Numbers that are less than 6, we have 5, 4, 3, 2, 1, 0, minus 1, minus 2, minus 3, and so on. Then set B is equal to numbers that are greater than 2 but less than 10. 3, 4, 5, 6, 7, 8, and 9. Then the union of A and B will be, we'll pick all the elements that are found in set A and set B. We have minus 3, minus 2, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So this is the union of A and B. Next, we will go to intersection. Intersection. The intersection of two sets A and B denoted by A intersects B, is the set of all elements belonging to both A and B. That is, A intersect B is equal to the set of all x such that x belongs to A and x belongs to B. That is the intersection of two sets A and B. Now let's take note of this fact. If the intersection of two sets is an empty set, then those two sets are said to be disjoint sets. That is, if the sets have nothing in common, their intersection will contain no elements, and as such, those sets are called disjoint sets. Now let's look at some examples of intersection. examples. If set A is equal to 1, 2, 3, 4, 5 and set B is equal to 3, 5, 7, 9, find A intersect B. Now we are given the two sets A and B. A is the set with these elements 2, 3, 4 and 5, while B is this set with the elements 3, 5, 7, 9. Then A intersect B is the set that will be formed by the intersection of the two sets A and B. How do we get this intersection? We pick out the elements that are common to both sets A and B. Those elements are 3 and 5. 3 is found in set A, 3 is also in set B. 5 is in set A, 5 is in set B. So A intersect B is this set with the two elements 3 and 5. Number two, if set S is equal to 4, 5, 7 and set Q is equal to 1, 3, 9, find S intersect Q. Now, if we look at these two sets, we will see that set S has the elements 4, 5, and 7, while set Q has the elements 1, 3, and 9. They have nothing in common. The two sets do not share any elements in common. Therefore, S intersect Q is an empty set. So these are two disjoint sets. Now let's look at complements. Complements. If A is a subset of the universal set U, then the complement of A with respect to the universal set is the set of all elements in the universal set which are not found in set A. Those elements in the universal set that are not found in set A, that is the set that will give you the complement of set A. Now we are going to look at a few examples on complements. But before we do that, let's see how to write the complement of a set. Complement of a set is denoted by this or this. So that's how to write complement of a set. Now, example. If U, the universal set, is equal to 1, 2, 3, 4, 5 and set A is equal to 2, 3, 4, set B is equal to 1, 3, 5, find 1, A complement, 2, B complement, and 3, the complement of A complement. So let's do this. A complement is a set of those elements that are in the universal set but not found in set A. Set A has elements 2, 3, and 4. Now, if you check in the universal set, you will see the element 1, the element 5. These elements are not found in set A, so it is the set of the complement of A. Number 2 is B complement. B complement is a set of those elements that are in the universal set but are not found in set B. Set B has elements 1, 3, and 5. So the B complement will be 2 and 4. And lastly, the complement of A complement. We already have A complement. A complement is the set with the two elements 1 and 5. Then the complement of A complement will now be those elements that are in the universal set but not found in the complement of set A. So this will be the set with the elements 2, 3, and 4. That is the complement of A complement. Okay, we are going to end this class here. Thank you for watching.